Hello students, welcome back. Today our discussion will be based on carbon and its compounds, another fresh new topic. We have discussed many topics previously and we have already watched all those things and have learned many things from those lectures. So today our discussion will be on a different new topic, that's carbon and its compounds. We know that we are very much familiar of this carbon, an element which is having we all the basic properties of atomic number 6 present in the periodic table, and according to having 6 protons and all those basic stuff. We already know that. But today our other aspect of discussion will be a slightly different one, that is based on certain properties of carbon, and definitely on some of the aspects, some of the preliminary differences between between two certain of the allotropes of carbon, and regarding and not will be not in this particular lecture we will not be discussing about certain or rather of its compounds. Okay, so let's proceed. Discussion, we will start with allotropes of carbon. Now, allotropes of carbon, while we already know, or we know that what does allotrope means. The word allotrope means the existence or of a particular element in different form, having different physical properties, but same chemical properties. Don't get confused with isotopes, because isotopes are also having the same chemical properties but different physical properties. But over here, what's another point which has been added with the definition of allotrope is different physical properties. That's the number one point, definitely, and different same chemical properties. But another point is the existence. That means the form, the entire atomic, or rather, the maybe the arrangement of the atoms within a particular form, the existence, the physical form of existence within the nature, the entire thing, the molecular arrangement, all these things are completely different in each of the allotrope. So that is what allotrope is. So allotrope is a substance of a particular element existing in different physical form, existing in different physical form. It's not about only having different physical property. It's not only having different physical property, it's existing in different physical form, and thus having different physical property, and but same chemical property. Many properties are almost same. So that's what allotrope is. Now, when we're focusing on allotropes of carbon, over here, this allotropes of carbon has been classified under two major subsections, or two major groups, categories. What are they? The first, they are crystalline allotrope and amorphous allotrope. Crystalline allotrope and amorphous. We already know that crystalline, this word crystalline means what? This word crystalline means what? Crystalline means the substances having geometrical structure, proper geometrical structure. That means they will have proper shape, proper arrangement no, along with the shape. That means when they're having the shape, the angles between the atoms are all having a specific of the geometrical angles. All the atoms are having proper definite geometrical angles, definite geometrical shape. But in comparison, amorphous, they do not have such proper geometry. They do not have proper geometry, and hence crystalline and amorphous. They are two different. They're two different. So one section crystalline, another one amorphous. Now this crystalline and amorphous has been rather is having actually all the allotropes. The crystalline allotrope of carbon considers or contains diamond, graphite, and fullerenes, and while the amorphous allotrope consists of the coal, coke, charcoal, lampblack, and gas carbon. So, if you're considering about with the popularly known, that is allotrope, that is diamond, graphite, and coal. They're not categorized under this. They are allotropes of carbon, but they are not categorized under the same group. So crystalline allotrope consists of the diamond, graphite, and fullerenes, while amorphous allotrope consists of coal, coke, charcoal, lampblack, and gas carbon. Under these categories, under these, or rather the substances, diamond is a substance. So all these substances, under these substances, particularly just charcoal, this coke is can be classified as a hard coke and soft coke. And major classification consists of the charcoal, which is having wood charcoal, sugar charcoal, and bone charcoal. Wood charcoal, sugar charcoal, bone charcoal. These are the major classifications of, or rather charcoal, as well as the all substances, the coke, coal, charcoal, or the diamond, graphite, fullerenes. All these have been classified under the different particular subsections of the groups. One is the crystalline allotrope, another one is the amorphous allotrope. Okay, now we will discuss about an allotrope of carbon. The name itself is given, it's coal. So we will have a very brief discussion, an overview of regarding coal. Now, what is coal? Coal is basically a naturally occurring amorphous form of carbon. It's formed by the bacterial decomposition of vegetable matter under extremes of temperature and pressure through the process of carbonization. Okay, this is what how it this particular thing, the statement rather covers up the process by which coal is formed, and what's the name of the particular process is. Now, this, if we look at over here, one point which is missing over here, that's I didn't mention, regarding that this extreme temperature and pressure, it's present basically within the soil. So deep within the crust, so deep inside inside the crust, there the temperature is high. So the high temperature and pressure, the high temperature and pressure, and by the bacterial decomposition. So vegetable matter means plants, mostly of plants. So plants, they get inside, or rather get buried under the soil, and over the time period, over the period, or rather in a long period of time, the they get exposed under extremes of temperature and pressure, and the process by the carbonization, it is leading to the formation of an amorphous form of carbon. That's what we call as coal, a completely black substance. Now, in terms of, if we need to define this carbonization process, we will write as this process of slow conversion of vegetable or organic rich matter into carbon rich substances, whether it's coal or petroleum products, is called carbonization. So the process, once again, I repeat, it's a definition that's of carbonization, the process of slow conversion. This is very, very important. A coal formation, it's not a matter of 1 or 2 days, or a week or 1 year. It's a matter of many, several hundreds and hundreds of years. It's a matter of hundreds and hundreds of years, or maybe, actually, it's a matter of thousands of years. So when this organic rich matter, it's basically vegetables, or maybe of plants. Vegetable means over here it's referring to, we are referring to plants, or our organic rich matter. When they're when they get exposed under extremes of condition, that's extreme pressure and temperature underneath the soil, and they get converted into carbon rich substances. That's basically coal or petroleum products. Those are carbon rich substances, but the process is very slow. It's a very slow process. As I said, it's not a matter of 1 month, or maybe of months or years. It's a matter of thousands of years. And this process, and that is called carbonization. Now, depending upon the formation style, the formation style, and the texture and many other properties, many other properties, this coal is being classified under four major categories. More major categories. What are they? There are different types of coal. The first type is peat. Peat is a for one of the type of coal. The second is lignite. The third, bituminous. And the fourth, anthracite. So there are four types of coal: peat, lignite, bituminous, and anthracite. But so many types of coal, as I said, there are four major types of coal, and then which property does it does or rather do govern within this, or rather do govern the formation of different categories, the different types of coal? Is it only the texture or the physical appearance, or there is anything else? Yes, there is something else which actually controls or which actually classifies these different types, or based on which that's a major, one of the most important parameter, based on which the coals or the coal has been classified on four different categories. And what's that? Carbon content. That is carbon content. So the carbon content of the different types of coal actually leads, or the carbon content of coal actually segregates or actually puts a boundary between different, rather within coal, to be classified under different categories. One category is peat, the second lignite, the third bituminous, and fourth anthracite. The obvious question will arise then: what is the carbon content? How much carbon needs to be present? If suppose if you're having a sample of coal, how will you understand this particular coal is whether it's a peat or lignite or maybe bituminous or anthracite? The answer is by the percentage of carbon present in the particular amount of coal. Suppose if you're considering 100 grams of carbon or 100 grams of coal, and after analyzing that particular coal, if we're able to conclude that particular substance or that particular coal contains this percentage, or well, this amount of carbon, then we can conclude that this coal is which type of coal. The first peat we'll consider is peat, lignite, bituminous, anthracite will have these other ranges. Peat will have 50 to 60% of carbon, lignite 60 to 70% carbon, bituminous 75 to 80% carbon, and anthracite it's 90% carbon. So if we suppose we're having 100 grams of coal, and if you're having 55% of carbon in it, that means it's a peat. If you're having 78% of carbon within 100 grams of coal, that means it's a bituminous coal. If it's if it is 70 or if it is 67%, then it's lignite. It's 92% anthracite. Then do we know, or rather, then obviously we are having, that means anthracite is actually the best variety of coal, and peat is the least, or rather best variety. This is the what should I say? It's not the best. It's basically the lowest possible category of coal available. So anthracite is the best variety of coal, while peat is the least, rather least in terms of quality, least in terms of quality, that category of coal, that category of coal, followed by lignite and then bituminous, and the top position is anthracite. Thus, since anthracite is having the highest amount of carbon, this particular carbon and coal is very costly. It's very costly. Peat is very cheap. So oh, anthracite takes a huge amount of time to get ignited. That once it gets ignited, it releases a huge amount of heat. So the worst variety of coal, that's peat, worst variety of coal, that's peat, that is giving out the minimum amount of heat after combustion. So when once it's come, so the amount of heat generated by peat when it gets ignited or after ignition, the heat of combustion or the amount of heat released after combustion, that's the least. And anthracite generates a huge amount of heat. So the amount of it takes time to get ignited, but after ignition, it releases a huge amount of heat. It releases a huge amount of heat. Okay. Now, the obvious now a question which is available, or rather, which is very very obvious, that why to use such a variety of coal? Why to use? There are various varieties. Why to use so many varieties? Now, definitely, so many varieties of coal available because the first reason is cost and amount of heat released. Peat is the cheapest, and anthracite is the costliest one. The costliest one. But now, the point is, all people cannot afford to buy anthracite because to buy anthracite you need money. So all people cannot buy anthracite. So you need, but for them you need to make available a lesser variety or a very cheap variety of coal, and hence peat lignite comes into existence. The second is amount of heat released. If you're focusing on that, I want a greater amount of heat, that rather which is very which will I need that amount of heat, then anthracite is the best one. Anthracite is the best one. So why anthracite? Anthracite is actually having so much, or releases so much amount of heat because of the sorry because of the high carbon content. High carbon content in coal is costly and releases a high amount of heat when ignited. So anthracite is having the high amount of carbon, which actually makes it costliest, and this that actually helps to release a huge amount of heat when it gets ignited compared to the other forms of carbon. Other forms of coal. Okay, so the amount of this high amount of carbon is always gets preferable. If you're working on on the perspective of that, I want huge amount of heat, that particular thing, and cost as well as cost doesn't matter. But if you want a between that, it is bituminous. Bituminous is the coal which is used by maximum of the people, because it is not so much costly, and it also does not give a very less amount of heat. It's a medium one, so it's affordable, and it's maximum of the people use bituminous coal. So bituminous gets ignited, and thus it is easier to use. But there's a very another important question. That question which is there, that is, when coal is burning, when coal is burning, it forms carbon dioxide. So that means whenever coal is burning, it will form carbon monoxide and carbon dioxide gas. That's obvious. But there is another point. The point is, what happens when coal is heated in the absence of air? That's another important point that needs to be taken, or rather that needs to be considered. We know that when coal is carbon and when it burns, it will generate like or rather carbon monoxide and carbon dioxide. These are very 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 polluting gases. But what about if carbon or rather coal is burned in the absence of air? What will happen? What will happen is it will form coke, coal tar, ammoniacal solution, and coal gas. So if coal burns in the absence of air, it will form coke, it will form coal tar, it will form ammoniacal solution, and finally coal gas, resulting resulting in or rather process of destructive distillation of coal. So this process by which this particular all these four substances are formed is called the destructive distillation of coal. Destructive distillation of coal. This destructive distillation of coal leads to the formation of coke, coal tar, ammoniacal solution, coal gas, and thus it is forming one solid, one liquid, or the two liquids and one gas. So when coal is heated in the absence of air, then that leads to the formation of coke, coal tar, ammoniacal solution, coal gas. The process is called destructive distillation of coal and leads to the formation, or rather, it forms one solid substance, two liquid substance, and one gaseous substance. Right? Of this, coke, the substance coke, can be classified as coke. Is basically of two types: hard coke and soft coke. You need to look at how coke and coal tar looks. Coke and coal tar looks like this. It's a very solid coal-like substance. Coke almost looks like coal, but very lighter than coal. Coke looks almost like coal, but quite very lighter than coal. And this is coal tar. You have seen pitch. The pitch which is used, or rather the liquid, the black liquid which is used to make roads, that pitch we will normally say that is basically coal tar, and that's totally black in color. We have seen dense black, intense black color, and that's basically and that's used or to make roads, right? Now, another important, interesting experiment that is which the scientists did, that when coal is, or rather, heated in the absence of air, the process called destructive distillation of coal, leading to the formation of coke, coal tar, ammoniacal solution, and coal gas. What will happen? What will happen if wood is exposed to such conditions? Wood. What will happen if wood is exposed to such conditions? Because we know that wood is basically related to vegetable or plant matter. So what will happen if wood is exposed to such conditions? Heating wood in the absence of air? Then that is also called wood destructive distillation process. Destructive distillation process. And it will form wood charcoal, wood tar, pyroligneous acid, and wood gas. The four substances: wood charcoal, wood tar, pyroligneous acid, and wood gas. Once again, one solid, two liquid, one gas. Similarly to that of coal. So destructive distillation of coal leading to one solid, two liquid, one gas. Wood destructive distillation leads to one solid, two liquid, one gas. Same state of matter, only the name changes. Over there coke, over here wood charcoal. Over there coal tar, over here wood tar. Ammoniacal solution, pyroligneous acid. Over there coal gas, here wood gas. Okay. Now, when we are so these are basically the general types or a classification of or a classification of or rather different allotropes of carbon, some different types of coal, and what will happen if wood is exposed to such harsh conditions. Focusing on the different types of charcoal, we're now having charcoal difference, that is wood charcoal versus sugar charcoal. Wood charcoal versus sugar charcoal. So it's made up of wood charcoal is made from wood and sugar charcoal from cane sugar. The process used in wood charcoal is destructive distillation, while sugar charcoal is just dehydration. Dehydration using concentrated sulfuric acid. Uh, Temperature that's around 900 degrees Celsius, and wood charcoal is almost greater than 3,000 degrees Celsius. Impurities, it's present in wood charcoal, and in sugar charcoal it's absent. It's a purest form of amorphous carbon. And wood charcoal's porosity is very high, while sugar charcoal is medium. And wood charcoal is used as an adsorbent and widely used, and sugar charcoal is a limited usage. Another very important difference, that is difference between coal versus charcoal. It's made from coal is basically made from jet plant and materials, and charcoal is carbonaceous materials. And process use is biological process. Charcoal is made from pyrolysis. Impurities is present in coal, And charcoal depends on the type, and porosity is very less in coal, where it's very high. It's comparatively higher in charcoal. Adsorbent in coal is not used, but charcoal is widely used as an adsorbent. Okay, so this is basically I've given a very overall or rather an overview of carbon and different allotropes and the properties of them and of different types of coal and its variation, the different rather parameters of differences, and some of the different kind of very interesting or common or other important differences between coal versus charcoal, or maybe it's considered versus wood charcoal versus sugar charcoal, whatever. So these differences is already discussed over here, and that's it. So that's all for this particular lecture. I'll catch you up with another interesting, important topic in my next session lecture. Till then, thank you so much. God bless you. Stay safe and have a very good time. Thank you.